by the end of the day, be able to start on your assignment. Hopefully you've kind of been going through, have you guys been using the tutorials? I get stuck, okay. Alright, so the tutorials are there, you've got all fun stuff there you can go through and look at. I mean, obviously if you've been doing like the choose your own adventure piece, you could use the tutorial for whatever software you were adventuring on. So I said check in on assignment 4. So I was trying so hard to get assignment 3 graded for you guys. Tried so hard. I'm not sure if you're aware of the software update that happened over the weekend. Yes, it was down. And so apparently Blackboard had some changes to it as well, which included the comment feature. Well, you know, I do your assignments and I put comments all over them. Yeah. So I'm at home last night. I was all excited. I was ready to go. I had to drink non-alcoholic. I had my hot cocoa.
Sure.
Anyway. I'm
I'm
sitting down and I'm trying and I'm working on it. And I'm putting this little comment bubble. And it would put comment bubbles all over the place. But I couldn't type in the comment bubbles. Try to remember browsers. Try to, you know, all the things that you guys do when stuff doesn't work. You're like, oh, it must just be me. No one. So I sent an email to the people. They got it fixed. So this morning I was crazy. And I got everything graded except your executive summary piece. So by the end of the day tomorrow, we'll have grades for that. So far, everything is looking really, really good. I don't expect you're going to be shocked at the A you should receive. I know how much. But yeah, so there's that. Assignment 4, you should be able to start by the end of the day. You should be able to finish. You're going to be doing the k-means clustering, and you're going to be doing the k-nearest neighbor on the Cleveland Park data sets. Things that have become interesting from my Saturday class. You just have to be careful about, you have to create a new variable. You have to be careful how you create the variable. So if you create it in Excel, and you create it using the formula in Excel, you can't just directly import that Excel file. You have to make sure to copy that, replace it with the actual values, because SPSS that we're going to use for k-nearest neighbor can't read Excel formulas. That's his painting here. So that's really the big thing. Other than that, things seem to be working out pretty well. So our goal for today, we're going to finish the KNN evaluation, so we're going to play on the software. Today we're going to do clustering, and we're going to play a fun game called Name That Cluster. Why not? And then we'll talk about your project just to make sure you guys are all on the same page. So, where have we been? Where have we been? You guys feel pretty cool with this slide? You like it? You've seen it enough? You think that one exam you're going to have is going to have anything to do with this slide?
I don't think so.
Just saying. Throw it out there. All right, so we've got our processes, we've got our categories, we've got our tasks. So far we've done estimation, we've done classification, and today we're going to do clustering. We've been working with our CRISP DM process. You've seen it lightly in your homework assignments. We go through it in class. On your next homework assignment with decision trees, you're going to see it very well mapped out. You're going to follow this entire process for that assignment. So far, linear regression, logistic regression, k-nearest neighbor, all those supervised. Unsupervised, we've done visualization, and we just talked briefly about the idea of principal components analysis, and I'll show you how to do that today when we do our k-nearest neighbor exercise. So where we are, I'm actually going to go back to last week's slides. And we made it as far as we looked at our pictures, I ran around the room, lots of fun, talking about how our algorithm worked. And we got to the idea of, hey, we can do this stuff in our software. The outcomes that we're going to be looking for are going to be the same as the outcomes we were looking for with logistic regression. Right? It's a classification technique. And so we're going to look for our classification or confusion matrix. We can look at our lift chart. The fun thing you'll see is we'll actually have an option that's going to help us choose the best K. So SPSS rocks in this faction because it actually tries all the different Ks out, all the different nearest neighbors out. It's going to help us predict or find our best predictors. We're actually going to do this, but here's the slides of what we're going to look at. It gives us a little three-dimensional predictor space of our top three variables, so we can kind of see really which neighbors are the closest. We'll play with that. It's going to be an interactive feature. And the best way to present results, and the best way to interpret these results, is going to be just to use some examples. Okay, so this is a data-driven model. We don't have an underlying formula that we're going to come up with. And what we're really going to find is we're just going to be able to find, well, here are my nearest neighbors. Okay, and kind of use some different examples. So for our evaluation phase, so this is going to be the what we're going to set up. And for our evaluation phase, we're going to click our little coincidence matrix. It's going to be great. Let's just get in and do it. We're going to go back to our eBay. We gotta have some data to do something. All right. So in your VMware, which I guess you guys have on your desktop there, we're gonna go play an SPSS modeler today. A little bit. Put it a little bit, but not a whole lot. So IBM SPSS modeler 18.1. Do I have eBay on here? So if you have previously saved the eBay dataset, life is good. If you have not, we're going to have to save the eBay dataset so we can use it. This is on the Blackboard. In your data sets, you should be able to find the eBay options data set. And just save it wherever you have access to. For me, I'm just going to save it on my desktop. And one thing that I would recommend, it is currently in a Excel 97 to 2003 workbook. As you save it, I would recommend saving it as just an Excel workbook, so a .xlsx. It's not a requirement, but SPSS is much nicer and much happier if you do that. And then make sure to close the Excel file. SPSS gets very, very mad if your data file is open at the same time you're trying to model. I'll give you guys a few minutes. Give me a thumbs up when you have the data. And you're in IBM SPSS. Finding the eBay data set, saving it somewhere you can access it, and opening up SPSS model.
Do we have to make any changes between both the data?
Once it's imported, we will, yes. Actually, I don't know. point, as long as you have your data saved somewhere and you have a blank screen, give me a thumbs up. Hear a little bit of clicking. Like when you teach like paper and pencil classes, they tell you to listen for like when the volume of students starts to get loud and then you know people are done. Here it's like when the clicks start to get quieter. Alright. So we're going to import our data. So up to this point, you guys did SPSS, you've done visualization. So that's kind of been your exposure at this point. Unless you've decided to choose your own adventure and try it out a little bit more. So I will go a little bit faster this part, but if you have questions, stop me. I'm going to bring in an Excel node. I'm going to double click on that so I can bring my data in. You'll notice the default is the .xlsx. You can bring in the .xls, but it generally gets bad because I don't support this anymore. So it'll let you do it, it's just not as happy with it. So now we're going to import the file wherever you saved it. Mine's on the desktop. This is going to be our eBay auctions data. I only have one worksheet, so I don't have to worry about this. I want to import everything. When I stop to hit blank rows, it's going to stop reading, so that's great. My first row has column headings, all of that's perfect. No changes needed. The filter option lets me filter out things, but I think all of these variables could be important, so I'm going to leave it in. My type, so my category is categories, different types of categories that this auctions could be. The currency is also a categorical variable. We had the US, I think we had pounds and euros. Seller rating is continuous, the duration is continuous, the end date is a categorical variable. Our open and close prices are continuous. And our competitive, this is the one we need to change, needs to be a flag variable. It's that 1, 0, was it competitive or was it not? And that's also going to be our target variable. Yes?
So we use flag whenever we always have 1 or 0?
Yeah, so flag and binary are the same thing.
Okay.
Different software, different words, all mean the same. So since we're doing KNN, it is a supervised training method. That means we're going to be a target variable. The last thing I'm going to do before I leave this screen is I'm going to make sure that I read my values in. Yes, read everything in. Oh, and then it even changes this. Like it's not even just categorical, it's nominal. And that's fine. So really, if I did this in a better order, you should probably read the values in and then change the measurement. It all should be good there. Everything's okay? Everybody's got their data in? I've got a lot of looking on other people's screens.
Wait, so inside a categorical.
Yeah, it doesn't matter. Either categorical or nominal is going to be just fine.
Okay.
There's no difference between the two. All right, so we've got Excel. So we bring our data in. That's step 1. What's step 2? We're going to try and do some modeling. Okay, we've got to prepare the data. So ideally, you would, let's see, so an output. Maybe I do a data audit node. So I'm going to connect Excel to my data audit node. So run that real quick. So the data audit node, you can find in the output. It's the 4th square over. And let's just really quickly, we've already looked at this data before, so we shouldn't have to worry about it too much. We see our nominal variables, we see our continuous variables, and our flags, so everything's kind of making sense. You don't have anything that's too crazy. we've already investigated, and we're like, yes, even though there's some very large numbers, we're still okay with it. So we have our business understanding. Our whole idea here is we're going to try to predict if this is going to be a competitive auction or not. We have our data understanding. We just kind of looked at it real quick. Our data is already prepped. There's not much to prep on this one. So now we're going to get into our modeling. So if we're going to model, what's the next thing we need? We got to partition our data. So in our field ops, somewhere towards the middle, you'll see partition. I'm going to connect my data to my partition. You can use F2, you can right click and do connect, whatever you're more comfortable with. I'm going to double click into my partition and change this to a 60/40. Okay, so we're going to have a partition. I've got a 60/40 partition. We have a seed. Right, so here, 1, 2, 3, 4, 5, 6, 7 is going to be our unique seed, so we're all going to get the same answers. Okay. Click OK there.
How do you connect second and third one?
How do I connect Excel to the partition? Questions, comments? Good? All right. So our ultimate goal is that we're going to do this K-nearest neighbor. So I'm going to do a couple different things. The first one I'm going to have you can follow along. So our next goal is going to be, let's go back so you guys can see this. It doesn't matter. Yes. Sorry, I heard you. So when you hit this, and this is a great thing, sorry, like this training and testing versus training and validation. So SPSS uses testing as the second data set. So whether you call it testing or whether you call it validation doesn't really matter. It's just that you have one data set at 60 and one data set at 40. So if you don't like testing and you want to make it consistent, you are welcome to change this to validation, and then it makes more sense with what we use everywhere else. So it's just an SPSS. So yeah, so you can leave it as training and testing, you can leave it as, you can change it to validation, all is going to be the same. It's going to do the same thing. So I'm going to put it back to testing, just so that way it's here. Alright. So the next thing we want to do. So ultimately our thing with K-nearest neighbor is we have this thing is that curse of dimensionality. Right? We can't have too many dimensions. It's hard to find. The more dimensions I have, when I say dimensions, I'm talking about those more variables. Right? So the more variables I have, the harder it is to find neighbors and to figure out where I'm along. So one of our options is we can do that principal components analysis. Okay, when we do that, it makes our interpretation a lot more difficult. So I'm going to do two things. I'm going to do one, I'm just going to go straight K-nearest neighbor, and we'll see what happens. And then I'll do another where we add in principal components analysis and see what happens. Okay? So the first thing we're going to do, we're going to go to our modeling options. You have to scroll to the right a little bit, and you'll actually find a K-nearest neighbor node. It's not alphabetical, it's not anything, just got to put. So you're going to find KNN, you're going to bring it back up here. So we're going to go straight from our partition into our K-nearest neighbor.
And do we need to standardize the data?
It's a great question. I love that question. Okay. So do we have to standardize the data for KNN? So we've got to somehow. So there are several ways we can do it. Right? So one is we're saying, I want to have some control over this. So KNN. So hold on to that for a second. So I'm going to go back to my field ops. And I can add it so at the very beginning it's the auto data prep. Okay, so it automatically prepares the data for modeling. So I'm going to put it up here, okay? Take this away. I'm going to connect my partition to this auto data prep node. So right now we're just kind of exploring and seeing what's there. So as we get into the auto data prep nodes, I'm going to double click on it and see what's happening. Here it asks me several different questions. It's like, well, if I'm going to prep this data for you, well, how do you want to do it? Do you want to balance the speed, how much time I spend with the accuracy of what I'm doing? Are you more, do we really need to work on speed here? Do you care more about the accuracy? What do you want to do? And most of the time, just balancing for speed and accuracy works out pretty well. And it says, okay, you have all these fields. So here we have, it's using the predefined roles. We're just taking the data that we have. You could use the custom roles, and then you could actually put in the target, put in the inputs, but we've already done that. We've already got that set up, so we don't need to do that. So we're going to use the predefined roles. We already set it up. Then we're going to move into our settings. In our settings, we have all sorts of options. So field settings are not effective if you change your objective. So we can filter out unused fields. Let's see, if the incoming field don't match the existing analysis, stop execution and keep the existing analysis. So if something's not matching up, so it's trying to prep it, and something's not working, it's going to stop and say, nope, let's go back to what you had to begin with. Okay. So here you could actually override that and say, nope, just whatever I did, clear it out and do whatever you think you need to do. Give the computer a lot of latitude there. Preparing dates and times. So if you have that date time field, remember how we had to go in and SAS, EG, and program it, and try to change things. Here, we can actually say how we want to do dates and times. So we don't really have to worry about that too much, because all of our dates are just like Monday, Tuesday, Wednesday. We can exclude certain fields. All right, so if I'm prepping the data, I'm basically going to say, if you have too many missing values, I don't want to use it. Okay, kick it out. And here it's 50%, right? Or if you have too many unique categories, right? So if you take the auto data prep and you go through churn, it's going to automatically kick out phone number for you. It's going to say there's too many distinct categories. You can't use this to do anything good. I'm just going to get rid of it and not even let you see it anymore. Okay, so these are some of the things that it's trying to do. Exclude categorical fields with too many values in a single category. So this one's actually kind of nice. There's a data set, it's actually the data set you're going to use for your decision tree. And one of the variables, like, everybody has the same answers. Okay, so it's like 2s for everybody. Or I think actually the question is, the variable is, are they over 18? And everybody that happens to be working at this place is over 18. So it's yeses for everybody. Okay, so that's not a valuable column at all. So you could say exclude categorical fields where everybody is yes. And what it's basically doing is just helping you, like, we're trying to reduce variables, right? We have variable reduction. This is one of the ways to help reduce our variables. Preparing our inputs and our targets. Yay! This is all this data quality stuff, right? We talk about it and we mentioned it in passing, but this is really, we have an entire node dedicated to making sure we got good data that we're going to model with. So we can adjust the type of numeric fields. It says ordinal and continuous. We've already really handled that, so we don't need to. But it would kind of say, hey, as I'm reading all these values, I really think it should be this variable instead of this. We've already set ours up because we know our data, so that's not really helpful. But we can reorder nominal fields to have the smallest category first and the largest category last. There may be an algorithm where that's important. This one we're working on today is not. You can replace outlier values in continuous fields. Right? So if you have outliers, instead of going in and you deciding that, oh, that 30,000 in our churn data set, I'm just going to make that 300, or I'm going to replace it with the mean. Here, it's just going to say, if I find an outlier, I'm going to replace it with it. So again, you're making choices, but you're given a lot of leeway to the computer system to kind of play with your data. So here, continuous fields replace missing values with the mean. Nominal fields, you're replacing values with the mode. If you had ordinal fields, you can replace it with the median. Okay, so some of these are checked, some of these aren't. You get to kind of decide. Down at the bottom, that's what we really care about for our KNN table. Let's put all continuous input fields on a common scale. So this is where, and you get to choose, do you want to do a z-score transformation, where we have a mean of 0 and a standard deviation of 1? Do you want to do a min-max transformation, where the minimum is 0 and the maximum is 100? You do your quiz where you had to do a min-max transformation yet? Cool, so when you do your quiz coming up, min-max transformation, that's going to be on there. Surprise! I think it must be on the class rate. And we can decide, do we want to standardize it with a minimum, and everything's going to go from 0 to 100? Or do we want it to go from 0 to 1? And so there's lots of different choices we can make. I am personally a fan of the z-score transformation. That's something I can think in terms of. I like the fact that a negative value means you're below the mean. Like, I can actually put some type of thought to it when I'm describing it. There's also another rescaling option you can use. If you're trying to reduce, like, if the variable's really skewed, you could rescale to do that. But for us, I think just leaving it as a z-score transformation is going to work. This one you'll notice is kind of all grayed out, but you actually could, and this is doing the feature selection. Another thing to think of, this is variable reduction. Yes?
To do the z-score transformation, do we need to check if the input variable is normal first?
You do not. So you can still do a z-score transformation even on a non-normal variable. It will still just be skewed. So even if your variable isn't normally distributed, you'll just have more variables that will be positive that are above the mean if it's skewed right or negative. So you can transform a variable to make it more normal, but it's not a requirement. And so this last idea, I'm going to leave this grayed out. We're going to talk through it too much, but you can dig in here and you can change all sorts of different things. So I'm trying to decide, do I want to include this in my data, do I not? So this auto data prep is actually a really cool feature in SPSS. And if we use it, so we're going to do z-score transformation. I'm going to click OK. So if we run this, I don't care about that. Something's happened, but we don't know what. Right? So wouldn't it be nice if we could see what our data looked like? So in your output, there's a table, and it says displays the data in a tabular form. So if I take that table, and I'm going to put two tables on here. I'm going to put one connecting it to just my eBay auctions, and I'm going to put one table connecting it after my auto data prep. And I'm going to run this variable. I'm going to run this again. So this is my data audit. I really could go delete that because I'm tired of running it multiple times. So here I have two fields. So table 8, this is actually my very first field. And this just has my data, just like what I would see on my Excel file. That's great. Yeah. Table 9, this is the one coming off of my transformation, coming off of my auto data prep. And it says, my competitive is staying at 0 and 1. Here I'm telling you, well look, I've been through this one. So observation 1's in the training data set. Observation 4 is in the testing data set. So you can actually see which data are in which partition. And then it has transformed all of these different seller ratings. So now everything is standardized. Let me take it back. All of the normalized, standardized. So all of the continuous values are normalized. So now when we get answers of opening price, that doesn't make as much sense anymore. So when we have our answers at the end, we're going to have to untransform them, unnormalize them, to actually be able to interpret. Yay! Alright. All the things we're doing. So that's great. But let's say, you know what, I mean, the auto data prep's cool. Let's do two different things. So let's take our auto data prep, and now let's connect it to our k-nearest neighbor. Now let's double click on our k-nearest neighbor. Let's go learn about it. So k-nearest neighbor procedure is going to identify the most similar training case by nearest neighbors. What type of analysis do we want to perform? We want to predict a target field. Right? That's our goal. Right? You could just try to identify nearest neighbors. That's kind of more of a clustering thing that we're going to get into later. Here are our ideas. We want to try to predict a target. So our fields, again, we're using our predefined roles, and all that's good. And then we have settings we can play with. Do we want to use partitioned data? Well, yes, we do. Do we want to build a model for each split? Yes, we're going to do that. Do we want to normalize the range inputs? And it's so important, it's built into the node itself. Okay. So we've already normalized them, so it's good to go. But if we hadn't, we could actually skip the auto data prep and go straight to the k-nearest neighbor, and we still have the chance to normalize.
I'm going to basically do the same thing.
Yeah. It'll be exactly the same thing. So then we get to choose our neighbors. So we could specify how many neighbors we want. Let's look at 3. Or we can say, you know what, SPSS, you're pretty cool. Why don't you just tell me which one's the best? Do a whole bunch for me. So here it says to go between 3 and 5. I like to go up to 10, sometimes 20. Right, try out a bunch of Ks. Let me know what happens. We can talk about the type of distance that you get to choose. And all these different options can potentially give you better or worse models. So the default here is Euclidean metric. That's like, it's your standard geometry that you've learned. The city block metric, the idea there is that geometry, you can only go in straight lines. And when I say straight lines, you can only go in horizontal and vertical lines. So think about, it's called city block, it's also called taxi cab. A taxi cab metric. So like think about how a taxi can't drive through a building. Right? It has to stay on the roads. Now, we could add weights to our features. So if we decide that one feature is more important than another, I mean, there's all sorts of different things we can change. Most of it we're just going to leave on our default. You can choose to use a feature selection or not. Right? So feature selection is the idea of a variable selection, the idea of variable reduction. Okay, so instead of throwing in all the variables, we could actually let this node say, you know what, why don't you find the best variables, kick out any that you don't think are going to work, and then work with a smaller subset. Right now we're not going to check it. We'll do it again and we'll check it and we'll see if we get a better result. The cross-validation, I'm not going to focus on that one right now. And for the analyze, you can actually add in, so what the k-nearest neighbor is going to do is basically, it's going to calculate probabilities of being the nearest neighbor. So it's looking for distances, it's going to find the smallest distances, and it's actually going to end up with a probability. And that probability, based off of our cutoff, our standard cutoff is 0.5. If that probability is above 0.5, we're going to classify it as competitive. If it's below 0.5, we're going to classify it as not competitive. And if you want to see what those probabilities are, you can save those. If you want to save the distances between the case and its nearest neighbors, you can save that. So you can do stuff with this if you want. Generally, I don't say these things because I don't get into it and I just look at this classification rate. But if you wanted to get in and see what's kind of happening behind the scenes, when we're finished, we can output a table of data and see what else is there. Alright, so at this point, we're going to run. Let's see what happens. So now we have our fun little nugget. Everybody have a nugget? So we double click in our nugget. All the fun output. That's fun. Anybody have anything in their little output? Oh, brilliant.
Got an error.
Okay, good times. This is why I hate live demos. Alright. So I'm going to do one thing real quick. I'm going to actually go and check these two things real quick and rerun it and see if that makes any sense. Yes.
If you click on preview on the top, it shows what the error is.
Scoring.
Error information.
That's what I get when I try to do too much. That means one thing.
Still getting
Alright, so really quickly, you guys can just hang out for a second. Let me see if I can fix it.
Yeah.
So this is the fun thing that my students were running into, and I'm like, oh, you must be doing something wrong.
Did the update broke everything?
I mean, I want to hope not, but it has broken a lot of things. I mean, it shouldn't have broken anything inside
Yeah.
inside of SPSS.
Broke everything, and we should just go.
I want to go home. I mean, yeah, I want to go home.
I was
No! 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 Alright. This is where we start to have fun.
Should we have added a type node?
You don't have to add the type node. So the type node will basically what we did inside the import, you can do within a type node.
Do we have to add an amount?
Not until we get answers to an app to analyze.
Okay.
So yes, that's the next thing. When you have something in the little nuggets, then the analysis node helps you dig into the nugget further.
Okay.
But we must have something in the nugget.
Hey, do we need space-time boxes? That sounds pretty cool.
I mean, you can try whatever you want to try at this point.
Space-time boxes. Can I use space-time boxes with this data? Would that work at all?
I don't really know what a space-time box is.
I'm gonna try it.
Ooh, it looks like a map.
Yeah, it looks like a map. Space-time.
Geo-referencing.
Yeah.
We could use that for Oxford projects. That is what it is.
Are we expecting that eventually we'll run into things that are in a different space? I don't know.
I think space is supposed to be
One more time.
Right, yeah, obviously.
It's just very funny.
We need
So did anybody get an answer? Okay. Check.
I only have like a few more characters.
To set this box to one that time you guys want and then reset the software. Yeah.
That's I did that. I did that way. The first 2 days.
I noticed that. So I started doing it for like the challenger
Alright,
thing. And
give
then
me 2 more minutes to try to figure something out, and then we'll try a different option.
when I'm competing on like the regular smash. Yeah. So I had a hard time repeating.
Just like going into regular like.
It's perfect.
You just go into just like regular like smash and you get people there.
Yeah.
Yeah.
Well, yeah, I mean, you can get the CD's level, but I mean, with the foe, the foe.
Oh, I see. Oh, I
Yeah.
see.
Yeah.
Yeah, you can't get that. Some of them are harder than others. I don't know if it says
I don't
they're back into the
I think it does because the one that I'm process I've gone through, seeing all the progress, now I just have to like, the ones that I missed. They're definitely like
Yeah.
it's just, when I tried it the first time, they were at least, but yeah.
You're seeing that right. Working over actually really hard.
Yeah.
Oh, it's Spence.
What?
Yeah, I think it was Spence.
Just a little bit of fire and a little characters.
Yeah.
It's just like really hard.
Yeah, through them for me, yeah. I played some issues now, which is very good.
Alright, so I'm not sure what has happened with the eBay data. Not sure why it doesn't like it.
Sniper attack.
I don't know. So for a second, because I didn't practice with the eBay data. That's my mistake. I'm just like, oh, surely this data set will work. So there's something happening with the eBay data that we're gonna have to play with. So if you guys will, for a second, hang out, and I changed over to the churn clean data set. You'll just watch me for a couple of seconds, and then I'll let you guys actually practice and try. I'm gonna go through the same steps. So I've got my churn data. I guess really quickly, I'm gonna filter out ID. I'm gonna filter out the state, phone. The types, I'm going to make sure that churn is a flag. Make area code a categorical variable. All the rest of this looks pretty good. I've read in the values, so all that should be good. So now I'm going to add in really quickly a data partition. Changing it to a 60/40. I'm not going to do the auto data prep. I'm going to do everything within the k-nearest neighbor node. run this. And what you should have seen, what we should have received with our eBay data, is something like this, where we actually have 3 variables. These are our top 3 variables. So down here along the bottom, when you actually get data, you'll be able to see, here's the predictor space, and here we're looking for our peers. So we can change this to be a neighbor and distance table. Let's try case selection. That,
That's because in Java there's no significant factors.
oh, your goodness.
Normally, would there be some?
Normally
It
there's a
wouldn't
bunch
just,
of, so,
it wouldn't just be a straight line.
so what I want you to see is this. You see why I take screenshots when it works. This is one of those days. So normally what you will see is you'll actually get to see, here is a case selection of 1, or this is 3, it goes from 3, 4, 5, 6, 7, and then when you get 8, it goes back up. Alright, so the best error that we can find, the smallest error, is the k equals 5 on this particular data set. So I guess, so here's my thought. You guys actually want to try and get one to work?
Sure.
Let's try it. Okay. Alright, back on Blackboard. You should have an H. No. Am I not saved? Yeah, let's try HMEQ. Let's see if that will work. Again, if you're saving it, make sure to save it as an XLSX. I'll tell you all about HMEQ in a minute. So theoretically, you should be able to just delete the data set and not have to change everything else. Sometimes that works, sometimes that doesn't. You want to just clear it all out? That's totally fine. So again, the goal is going to be bring in a data set.
What is our target? I'm not using target.
Drag
We're long.
yeah.
Even error there are I cannot read.
I can't delete the data.
That's a rare answer.
So the reason it couldn't, as I said, the reason it couldn't read my data was I left my Excel file open. It gets really mad at me. I'm going to exit my Excel file. I'm going to try it again. I was like, oh, okay. Now I can do it. So bad is going to be a flag variable, and it's going to be our target variable. No. So HMEQ is a home equity data set. Basically, we're trying to predict if somebody will be a good risk or a bad risk. So bad is a bad risk. We should not extend them. So we have information such as the amount of their loan, the mortgage due, their job, how long they've been on their job, if they've been delinquent in any payments, their debt to income ratio. Those are what some of those variables are. The idea is, should we give them a home equity loan or not? Once you have your data all set up, again, bad being a flag target variable, then we can go in and we can add, if you want to, you can add a type node. All the type node does is shows you the type of what we just changed. So sometimes this will be important, sometimes not so much. We have our data, we've got it set up the way we want it to be set up. I'm going to add my data partition.
What would be the target variable here?
Bad. Going back and I'm changing my partition. I'm going to skip the auto data prep. I'm going to go straight to my K nearest neighbor. And you'll notice that if everything works right, when I go from KNN and I connect it, it should turn into my target variable of bad. Now, just like in any other software, if you right-click, you can always rename things, right? So maybe you want this to be KNN bad. And now we should be able to run this, and hopefully something will work.
This.
Yes. Results. Hey. All right. When you get some results, you can double click on our nuggets. Let me know when you get there.
I suggest trying to rotate the graph.
When you get a picture or something very similar to this, give me a thumbs up. Okay. So some things that we can notice. First of all, if you look at the values, or the loan, or the mortgage, those are the actual values, the actual loan, and the actual mortgage due. Have they been standardized? It doesn't look like they have to be. Okay. Now we gotta go back and make sure things are standardized. So in my bad, I forgot to click. Here's my field, there's my settings. It's weird because it does say normalized range inputs. So is it normalized? So yours are.
I kept the path, I just deleted the source.
Oh, okay. So you actually keep the automated prep in it? Yeah. So here, it says normalized range inputs, but it doesn't tell us how it normalized them. Right? So when I say normalize, I think on a 0 to 1 scale, but we haven't really defined that. So yes, it may have normalized our inputs, but we don't know why and we don't know how. So this is a reason that maybe we do want to have the auto data prep, because then we have more control. So I'm actually going to go ahead and add back that auto data prep. In my field ops. Move it auto data prep in the middle. In the auto data prep, I want to make sure that I'm going to normalize with the 0, 1. And on my bad, I'm going to make sure that I go from 3 to 10. So I'm going to check out several different variables. Okay.
Ready?
All right, we'll try this again and see what happens. So now you see mortgage due and it says underscore transformed. So same variable, but now we've transformed it so it's all on the same scale. So we've got our value, our loan, and our mortgage due. So still the same 3 most important variables, but now just on a different scale. So again, were the other ones normalized? Probably so. We just don't know how they were normalized. So trying to deconstruct that and interpret it is going to be a little more challenging. And so this is where the software is awesome. It does a lot of cool things for you. But you also give up some control at different places. So what we can do now is we can actually pick one of these places. So like, here's an observation right here. You can actually click on it. And when you click on it, then it gives you this peers chart. Like, so who are my buddies? So I picked option 1440. And my 3 nearest neighbors, because over here I have k equal to 3, are observation 2366, 2627, and 2397. And I can tell you that I'm a bad investment. I'm 1. And they're all good investments. I can tell you that I have a low loan transformation, and they have higher. Same thing here. I have this low value, and they're higher. So what am I like them? Like, I seem like I'm pretty different from them. But I'm close to them here. On something different. You what?
Derogatory marks.
Yeah. I'm not exactly sure what that is. Okay. But it makes sense because my nearest neighbor, I'm not really close to anybody up here. Right? I am kind of far away. So the closest I get is on this other variable that you can't really see. What if I pick somebody in the middle? I don't even know who it is. I just pick somebody in the middle. Or if we want to all pick the same point, somebody like closer right here, like this 2219. So just a little bit closer. So now it's going to be a little more like some of its other peers. The more in the middle you get, the closer and closer I get to my peers. So it makes sense the people on the fringe aren't as close, but I had to get them close to somebody. The people in the middle are really close to each other, and you can find out who we're really close to. Okay, so that's one of the cool features here, is like you can actually look at it. You can select the predictors that you're interested in and just look at certain ones. Another thing in the drop-down menu we can do here is we can actually look at the K selection. So this is kind of what we were talking about. So here, by far, using 3 neighbors gives us the lowest error rate. Once I get up to 4, I have almost, what, a 3% increase in my error rate. And then 4 and 5 are the same, and then when I go 6, it's bigger, then 7, 8, and they start kind of going back and forth. So here, having that close-knit group is going to give us the best, or the smallest error.
Too low.
2 is generally too low. 3 is really where you want to start. And a lot of the reason is you don't want to just do 2 neighbors. So if you just do 1, it's just itself. If you do 2, it's itself and 1 other point. So once you get 3, now you've got 2 other neighbors you're actually. So now we actually have the results. That's kind of what it tells you. You can play through the other options. It tells you that overall, there was an 11% misclassification rate in the training data set. It doesn't tell you about the validation data set here. It gives you, this doesn't always happen, but here it actually gives you a classification table. But notice that this is just for the training data set. We're interested in the validation data set, what happens next. Okay, so this is good to start with. You're 88.9% correct. You've got the, in this case, good. You got all the goods pretty well. You missed a little bit here, so you can look at your false positives and false negatives, again, on your training data set. But I'm more interested in that validation data set, so how do I get that? And that's where I'm going to exit out of this output. And on my output, there's more output that I want to see. So I would like to see an analysis. Tell me more. So I'm going to connect my results to an analysis node. When I double click on analysis, the very first thing at the top is coincidence matrix. That's what I'm looking for. And you can click on other things and see what they are. Here, since we have binary classifiers, we could do this evaluation matrix if you wanted to do the area under the curve. We don't really talk about that a whole lot. There's other things that you can look at. We're going to separate by our partition. This is really what I'm interested in. So I'm going to run this. And we have more errors. Yay! Yours works? Oh, good. Does everybody else's work?
No.
No. Mine worked. Mine
Alright, I've got 2 errors.
When
Sam
connecting
has
the partition node to realistic,
partition node to.
this is, this I can just go back to that's the red line.
Right, so this happens. For that. If I rerun this real quick. So I had a little extra connection there.
But still it's not working for me.
Oh, it's still an issue. Like yes, but it's still on it. So here I have no matching pairs of target predictor filter bound.
Maybe you will connect auto trader.
Alright.
Trying to run it without it, it's going to tell you to not execute that.
And this is the fun. So hopefully we're running into these problems today together and we'll fix them so that. So that's what I should be expecting, right? So from my audit data prep, so there should be an extra line here because that's basically connecting the data that we have to the output. So why shouldn't it look from the partition? It should go from the auto data prep. So does everybody's model look like this? Okay. So then we still had output. So that was good. So then when we added on the analysis node, we ran the analysis node.
So the tool itself by making the wrong thing.
Yes.
Cool.
So one of the great things about SPSS, when it works, it's awesome. But it has a bad problem of storing things in its memory And you really, it's hard to go back and change things in your flow. So if you run into an error, and I hate to say this, but when you run into an error, the delete and start over is one of your best friends. Luckily, our models aren't too complex, so that's not too hard for me to do. But it'll store stuff in its memory, or like, so I had it connected because I went back, and when I ran the model the first time, it went from the partition because I didn't have that auto data prep. So basically, it's coming from the partition and saying, hey, the data is going into this nugget. Right? But then when we say this nugget, it's like, hey, now we have this lone transform. It's like, but I'm looking at the partition, and there's no lone transform. So we've got to make sure that the data are coming from where I've transformed my data. That's the data that I need. Another way to fix this, and I'll show you this, and then we'll take a break, is like when we're going to do our principal components analysis, using that type node actually does become important. So real quick, let's do this analysis. Let's get this output. So in our analysis, if you check the coincidence matrix, we'll click run. Then hopefully what you will get, you have this top part that's going to happen, and it's just going to give you the correct and the wrong. So it's just going to give you your misclassification rate, your accuracy rate. When you click on the coincidence matrix, then it actually gives you more details. And it separates it by the training data set and the testing or the validation data set. And that's really the data set that we're interested in. So we trained it, that's great. But when we put in new data, how did it do? So ideally, we would want these values to be very close to each other. And we want the percent correct in the training to be very close to the percent correct in the testing. If not, maybe there's some overfitting happening.
Okay. Another question: how is this? I guess I'm confused how this is working because, like, with the logistic model, it made sense in the sense of like it comes up with a model in the training and then it tests it in like the testing. But since this is like a data-driven model, like how is it doing that? I guess.
So it's still the idea. The idea really here is we're just trying to find that magic K.
Okay.
That's really what we're trying to find. So in the training data set, we're deciding what K do we want. And then the testing, the validation piece is we're actually using that K.
Okay.
And then it just says, so here's this new data. I'm going to use this particular set of numbers, or this particular set of neighbors. I'm going to run through my algorithm. I'm going to check out the distance, and I'm going to create a probability. Right? So if we're trying to classify things, the probability that we're looking at is, so if we have 3 neighbors, well, let's do 4 neighbors because it's easier mathematically. If I have 4 neighbors, 3 of them are 0, and 1 of them are 1. Then the probability is going to be 0.25. It's just the probability, so it's 1 out of 4 possibilities. So the probability is 0.25, it's a fourth. And 0.25 is less than 0.5, our cutoff. So I'm going to classify you as a 0. And so what we've actually done, right, if we actually talk about our table here, so out of this output, what does the data look like? And we didn't keep the probability of the thing, so we have to go back and look at it again.
Where do you get the misclassification?
When you add in the analysis node,
Yeah.
so the analysis node, by default, it will give you this classification rate. If you click on the coincidence matrix, then it'll give you your false positives and false negatives as well.
Or this classification. Yeah, that's it.
So if you actually put on a table, then what you can see is now we have these data points, we have these partitions, we have our lone transforms. Here's all of our transform values that we're using.
Can you use all the
Yeah. And then we'll have, so this $sign KNN bad, this is what the model has predicted. So for number 1, it predicted a 1. Now in reality, we can go back and figure out, oh look, it was actually a 1. And so you can actually check. So for number 2, so let's do, so 1, 2, 3, 4, they all predicted it was all actually a 1. Here it predicted 1, 1, 1, but here it actually predicted a 0. So this is our misclassification. This is one of the values that our model got wrong. That's what all these values and things are. The next column, the KNN P, that's the probability. So if it's a 0.8, you're getting a 1. A 0.6, you're getting a 1. And that's what, that I get. So this right here should have been a smaller than 0.8. Now I'm going to have to go double check that.
They're all 0.8 or 0.6.
I know. Okay.
Is our cutoff value?
I mean, our cutoff value should be 0.5. We didn't change it.
Was it,
Now I'm going to have to go back and figure that one out.
was it at 0.8? Is that the dividing line? Exactly 0.8?
I mean, I would have thought it was 0.5 as the default because I don't think we changed it.
Because if it's...
But the 0.6 here, we still got a 1. So I just may not have the right interpretation for that
Then
column.
there's a 0.6 that has a 0.
Yeah, so I may just not have the right interpretation for that column. So on the break, I'll look that up. Yes. 1 second. Yeah. Yes. Maybe that's big.
I don't have a 1 train or 2 test.
Okay. So what you'll need to do in your analysis, make sure to check this first thing. That is the coincidence matrix.
A minute ago it locked up and had to sign all the way out and come back in because I don't know how Michael worked because my auto prep froze up. This is the first 2 or 3 times I tried to run it, it said it was an error, so it was still looking for the values in the last data set. But then when I ran it a 3rd time, it was locked up.
And that's why the delete and start fresh is really amazing.
Because it wouldn't even, it wouldn't even close out of the other eventually.
And it's, which is, so like I said, SPSS modeler has a lot of really good fun things to do. It also has a lot of really weird errors that trying to figure them out, generally, I wind up just deleting and starting over. So your adventure for your assignment is to see if you can actually get this to work. It does work with the data set I provided for your homework assignment, so I have decided on there. Everything should work. And then you get to investigate any of these things you want to play with and investigate and see what happens. If you start with just a very basic model, you can add in, the one thing we haven't added in, risk it. If it works, great. If not, we're going to take a break. Is we can add in the principal components analysis. The last thing we're going to do is in our modeling, there's a PCA/factor. So we could add that in.
That'd be after the auto data.
So we've prepped our data. Now we're going to say factor it. So instead of having these 3 variables that we're looking at, now we're going to see, can we combine some of these variables to make fewer variables? So I'm going to do a PCA, so I'm going to delete. We'll have to delete everything after this to make it easier. I'm going to do, from my auto data prep, I'm going to do a PCA factor analysis. From there, I'm going to attach a k-nearest neighbor node.
Thank you.
Let's see if it's right. Oh, it's not letting me. Come. Let's try and connect. It's like, oh look, it won't let me connect to PCA to anything.
Okay.
Ah. So what we're going to need to do is we actually have to run this lovely little first piece. And then our PCA is going to say, well, hey, this is kind of cool. Let's see what we get. So what this has done is it has actually taken all of these variables and it's combined them into 5 different factors. Interpretation now becomes really crazy. So I wouldn't ask you to interpret it. What I would ask you to do is tell me who are the nearest neighbors. Now you could deconstruct it, you could totally interpret it. But we're not trying to interpret it in terms of a model. We're just trying to say, once I have this model and all the craziness that happens, if I take a new data point and I plug it in, how likely am I that I'm going to get it right? Right? It's all about prediction. It's not about explaining what's happening right now. Okay? So what we've done is we've taken all of our variables, so all 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 of our variables, and now we're going to combine them into 5 variables. And so we've shrunk the number of factors.
Do we connect the output of PCI to that?
So now you're going to try and connect the output of PCA into the k-nearest neighbor.
Let's run it.
Let's see what happens.
I'm gonna get an error.
Yeah.
Okay, so it says type insufficiently specified for factor 1.
I'm just always getting 5 times worse.
So if our type was insufficiently specified, maybe we should have a type. So go back to our record ops, or our field ops, and add in a type. So from our PCA, now we're going to add in a type. And when you double click on type, you'll see all of our original variables.
First 30 seconds.
These are transformed variables. And if you go down to the very bottom, you're going to see factor 1, 2, 3, 4, 5. But you'll notice that they have not been read in yet. We got to read our values. Now it says, oh, so you want these to be continuous values. Now I'm good with that. So now if we connect our type to our k-nearest neighbor and run that.
Right.
We're going to cross our fingers that it works. Okay, so it's coming, so our node is coming, here's the data that we use, and here's the model that we use. So when we double click on bad, we've got variables, and it does look exactly the same. Why does it look exactly the same?
Because we're good at our jobs.
What variables are you using?
Same thing.
We're still using the same ones.
Alright, give me 2 minutes.
Do I still want to use the same variables?
Isn't that validation?
So here's your options.
You want to use that validation?
So that's the question. Do I want to use the 5 I just created? Or is this saying, so right now this is basically saying that these 3 variables are doing a better job than the 5 that we created. Now if we wanted to say, no, I've shrunk this and I want to use these 5, then during that type node you have to get rid of all your other variables. But what we've just figured out is that these 5 variables that we created using the PCA not actually better than just our original variables.
We've done all this for nothing.
Not always the case. Sometimes the factors are better. In this case, they happen not to be. That is a crazy tutorial on
I don't know why mine is going so
SPSS and k-nearest neighbor. The one thing that was going to take 30 minutes of class that is now taking an hour and a half, but your assignment, hopefully, will now be much easier because you've run into these problems and we've tried to fix them here, as opposed to doing this on your assignment on your own. Hopefully, this will be good for you. Yes.
So then, I guess I'm just so confused, like, from this. So then if you're, like, just thinking ahead, like, okay, I want to use this model in a business, then, like, what do you do? Like, what are your...
Right, okay, so... So Will over here, he's like, you know what if I actually want to use this? You know, the deployment phase, right? So we had our data, we understood our question, we cleaned our data, we understood our data, we modeled our data, we evaluated our data. We didn't really evaluate it, but if we had more models, we could say, oh, this model or the other model's better. Now we want to actually do something with it. So what actually happens? And I'm going to be honest with you, I have not done this in SPSS. I can show you how to do it in SAS really easily. We're not going to do it here. I'm just going to see if it's obvious. So my guess is what we'll do is we will import a new data set. And we will, so like if I imported, pretend here, so I would import a new data set. And I would take that data set and I would connect it, and it's not going to let me because there's no data set there. But I could actually connect this data set to this node, and then I would run the new data through my model, and I would output. And then I'd be interested in the table. I would actually be interested in, okay, so here are my values that I put in, here are the values my model spit out, and now I could actually apply that.
And in that new data, you wouldn't know, like, the target.
I wouldn't know the target variable. Yeah. So in SAS, it's called, there's actually a scoring node. This is called scoring. So when we're modeling, we have our training and our validation data sets. But our third data set, like when it's actually this brand new data, we're basically scoring our model and saying, okay, here's new data. I don't know what the target is. Model, let's see what you can do. And then that would be like, so if we were going to send out targeted mailers, it would be, okay, I figured out who I think are going to be the best things. I'm going to put new information in. I'm going to see what it plays it out. If you get a 1, I'm going to send you a mailer. And if you get a 0, I'm not going to. And so then you can actually put it to action.
Okay. And so the model that we're looking at here that has the graph and all the dots, that's like the actual data.
So that's the actual data.
That's there. And it's just saying, it's putting it somewhere in that graph based on like those 3 values.
All about the distance.
Right. And then it's predicting based on whatever other values were around it
Yes.
from the same data. So I'm just trying to understand what that means.
Okay. Yeah, absolutely. Any other questions?
More.
Okay. All right, well, it's 10:15. Let's do this. And we'll come back.